Today we're going to be talking about radicals, so things like square roots and cube roots. And I think you'll find the first part of this discussion to be review. But then we're going to talk about something that is probably going to be new to some of you, the idea of writing radicals as exponents and doing some math with those exponents. So let's start by reviewing what it means to have square roots and cube roots. Square root of 49 is 7, because 7 squared is 49. It's okay to have fractions in square roots. Square root of 1/9 would be 1/3. And in fact, you can actually take the square root of the numerator and denominator separately. So root 1 becomes 1, root 9 becomes 3, and so that's one way of getting that answer of 1/3. Now, square root of -9, we're trying to figure out what squared is -9. It turns out that isn't possible. There is no real number that you can square and get a negative number. And so you could write no solution. I'm going to write not a real number. So we can't take the square root of a negative number. However, it's okay to have a negative outside of the square root. That simply means your answer is going to be negative. Root 9 is 3, so negative root 9 is -3. Now, if you want to take the square root of something with an exponent, you can actually just divide the exponents by 2. That's because when you square something with exponents, you multiply by 2. So square root of x squared is x to the 1. Using that same reasoning, square root of a to the 4th b squared would be a squared b to the 1. I just divided the exponents by 2. Now higher roots work the same way. With a cube root, we're trying to figure out what cubed is 8. And the answer is 2, because 2 cubed is 8. Now it's okay to have a negative number inside a cube root. What cubed is -8? Well, if you cube a negative number, you will also get a negative. So cube root of -8 is -2. And so the idea is you can't have a negative number inside an even root, like a square root. But if the root is odd, like a cube root or a fifth root, then it's fine to have a negative number. If I want to take the cube root of something with an exponent, I can actually just divide that exponent by 3. So cube root of x to the 6th is x squared. And the reason we divide by 3 is because if you're cubing something, you would multiply that exponent by 3. Fourth roots are similar. What to the 4th power is 81. You might have to use a little bit of trial and error. It's fine to use a calculator here as well. But the answer is 3, because 3 to the 4th is 81. Now, what to the 4th power is -81? Well, you can't have a negative number inside an even root, and so that would include fourth roots. Just like when we were talking about square roots, we can't have a negative inside a fourth root. And finally, if we want to take the fourth root of something with an exponent, we can divide that exponent by 4. So fourth root of x to the 4th would be x to the 1. Now it turns out every single root can also be written as an exponent. X to the 1/2 is the same thing as the square root of x, and x to the 1/3 is the same thing as the cube root of x. That pattern continues. If you have an x to the 4th, it's a fourth root. X to the 1/5, it's a fifth root. Now the second formula or rule I have written down says if you have x to another fraction, like x to the 3/4, the number in the denominator, the 4, is the root, so that's a fourth root, and the number in the numerator you can think of as an exponent. So x to the 3/4 is fourth root of x to the 3rd. Now let's see how this works with some examples. So example 2 says write in radical notation, then simplify. As a radical, 9 to the 1/2 is square root of 9, and this simplifies to 3. As a radical, 27 to the 1/3 is cube root of 27, which also simplifies to 3. Now 4 to the -1/2, we have a negative exponent there. Now anytime you have something with a negative exponent, you can actually rewrite it with a positive exponent, remembering that negative exponents mean reciprocals. So 4 to the -1/2 is 1/4 to the 1/2. that exponent of 1/2 is a square root, and square root of 4 is 2, so I get the fraction 1/2. 25 to the 3/2 can be written as square root of 25 to the 3rd. The 2, the number in the denominator, tells me what kind of root it is. Now the order you do these operations in doesn't matter, so I'm actually going to square root the 25 first and then cube it. Square root of 25 is a 5, and 5 to the 3rd is 125. Same idea with example E. 27 to the 2/3 means we have a cube root of 27 squared. Number on the bottom is the root. I'm going to do the cube root first, and cube root of 27 is 3, and then I square it. 3 squared is 9. All right, one more example. This one also has a negative exponent, 8 to the negative 2/3. So I'm going to write it with a positive exponent first, 1 over 8 to the 2/3. That 2/3 power becomes a cube root of 8 squared. Cube root of 8 is 2, and 2 squared is 4. So 1/4 is my answer. Now in our next set of examples, we are going to be working with these rational exponents, fractional exponents, but we're going to have to remember the laws of exponents to help us do some simplification. So I have written out on the screen the laws of exponents. The product rule says if you multiply something with exponents, you add the exponents. So an example would be x squared times x to the 3rd is x to the 5th. The quotient rule says that if you want to divide and you have exponents, you can subtract the exponents. So x to the 7th divided by x to the 4th is x to the 3rd. Finally, our power rule says if you're going to take an exponent and raise it to an exponent, that's when you multiply. So x to the 3rd to the 4th is x to the 12th. And finally, if you have a product or if you have a quotient raised to an exponent, that exponent applies to each piece. All right, so let's do some practice. I'm going to use the laws of exponents to simplify, and then it says write your answer using positive exponents first. So the first thing I'm going to do is get rid of the parentheses by multiplying the exponents. 3 times negative 5 is negative 15. Now because I have a product, I add the exponents. 4 plus negative 15 is negative 11. And finally, because they asked for an answer with a positive exponent, I'm going to write that as 1 over y to the 11th. Example B has a quotient, b to the negative 3 over b to the 4th. The quotient rule says we subtract the exponents. Negative 3 minus 4 is negative 7. And b to the negative 7 is 1 over b to the 7th. Now these same laws of exponents apply even if you have fractional exponents. It's the same rules. So x to the 1/3 times x to the 1/2, that's a product. So I'm going to add the exponents. I'm going to need a common denominator to add. I'll make 6 my common denominator. So I get 2 over 6 plus 3 over 6 is 5 over 6. And so my answer is x to the 5/6. Now in part D, I see parentheses. So in part C, it was a product. We were multiplying. So we add the exponents. In part D, we are raising something with an exponent to another power. This is the power rule. And so here's where we're going to multiply the exponents. When we multiply, we don't need a common denominator. We just go straight across. And we get negative 3/10. I'm going to write my answer using a positive exponent. So I'll write the answer as 1 over b to the 3/10. In this next example, we have a quotient. The quotient rule says we subtract exponents. Minus and minus becomes a plus. And again, I'm going to need a common denominator. 8/20 plus 15/20 is 23/20. So my answer is x to the 23/20. Finally, we're going to put all this information together. We're going to be given problems that have radicals. And the directions say write with exponents, then simplify, then write with a radical. Okay, so we're going to put together everything we've learned. The first thing I'm going to do is change this problem so it has exponents. Square root of y is y to the 1/2, and then we have that extra square root. That's another 1/2 power. When we have parentheses, we multiply the exponents. 1/2 times 1/2, we just multiply straight across, and we get 1/4. So y to the 1/4. Finally, they ask us to write this as a radical, and y to the 1/4 is the 4th root of y. So we've basically just shown if you take the square root of a number twice, it's the exact same thing as taking the 4th root. All right, last example. We're going to write with exponents, use the laws of exponents, write as a radical. So square root of x, that's x to the 1/2, and cube root of x is x to the 1/3. This time we have a product, so we're going to add the exponents. 1/2 plus 1/3, I think we actually did this problem earlier today, and we got 5/6. So this becomes x to the 5/6, and then finally, we're going to convert this back into a radical. The number in the denominator is the root, so this is 6th root of x to the 5th. All right, that's it for today. Let me know if you have any questions.